Okay, we're going to be demonstrating safety on a table saw. The table saw is the most universal equipment in the shop. You can do a number of things with it that you have trouble using hand tools or handheld power tools. It's just so much easier to use this and more accurate. So with that, we're going to go over the basic safety features. The first safety feature is this right here. This is the guard, and built into the guard are two more safety features. To show those, I'm going to remove the guard. I simply remove the throat plate, pull up a lever, and now we have the guard. This part is called a splitter. Its purpose is when you cut through a board, the wood removed by the saw blade is called a saw kerf. And this is used to emulate that saw kerf. So when you're pushing the wood through, it is going to maintain that saw kerf. Wood naturally, in the growing process, drying process, has internal stresses build up, and you're going to be relieving some of those stresses as you're cutting through the board. Most of the time, it will go through, no problems, cut nice and straight. Once in a while, it is going to do this. Once in a while, it's going to do this. But worst of all is when it wants to do this. It tries to close up that saw kerf as it's going through the saw. That's the most dangerous part, because what that does is when it closes, it clamps onto the saw blade, and that saw blade spins at 103 miles an hour. So the saw blade is going to throw that workpiece back at you at 103 miles an hour. Now, to put that into perspective, imagine catching a pitch from a Major League Baseball pitcher at 103 miles an hour, trying to catch it with your face. Does a lot of damage. So always do whatever you can to avoid the kickback. So with the kickback, now we can go on to the next safety feature of the guard. We have the guard, we have the splitter, we have these little devices here. They are called anti-kickback pawls, P-A-W-L-S. And they work on a cam mechanism, so if the workpiece is starting to be pushed back towards you, it is going to actually dig these teeth into the workpiece, and since this is a solid piece of metal, it's going to stop it and hold it in place rather than kicking it back towards you. To reinstall this, I hold these long anti-kickback pawls up, drop it into place, clamp it down, drop the guard, and we're ready to go. What this piece does right here is shows you where the top of the saw blade is, so you can easily adjust the height of the saw blade without lifting the blade up and going through it any other way. But if you don't have that, you simply just lift the blade guard up and you check to make sure that the blade is set at the proper height. Okay, so the next safety device is the fence. The fence is used to make rip cuts. Rip cuts is the cut with the length of the board. And its purpose is to guide the workpiece straight past the saw blade. And you always make sure that the workpiece goes all the way past the saw blade before you let go of it. You have to be in control of that all the time. If you stop short, now you have that workpiece caught between the saw blade and the fence, and you've just increased the chance of a kickback dramatically. So you always push it clear past the saw blade. The next thing to think about is the width between the saw blade and the fence. If it is more than 5 inches or 5 fingers, you can use just your hand to guide it past. The problem is if it's less than 5 inches, now you have the chance of getting your hand caught in there. So you use a device called a push stick. This is the most basic type of push stick. And you just push the workpiece through there. Gives you clearance, keeps your hand up away from everything, and you always push the workpiece all the way past the saw blade before you let go of it. The problem with this is when you're doing long workpieces, and with this, I've got a push stick clear out here, and the workpiece can actually ride up on the saw blade as you're making a cut, and then it's going to run into the splitter, everything's going to stop, and now you have everything up here, your hands up here, and your attention, all of that, but now you have to stop the saw. Fortunately, with the saw stop, the on-off switch is right here. You just hit it with your leg and it'll shut it off. But with other manufacturers, sometimes they have the on-off switch out of the way, so you have to look underneath the table saw to turn it off. You've diverted your attention from up here, holding everything into place, to down here, so you've increased the chance of kickback and or injury. So the push stick that I like is this type of push stick. It's longer, it's got a hook on the end, so I can put that hook right on the end of the board, push it through, but I can also hold the board down up here, so I'm more in control of the board as I push it through the workpiece, or push it through the cut. So with that, if I check, I see that the front part of the guard here, I've got just a little air gap. I'll adjust it up a little bit higher. I can double check to make sure that I have the blade height set correctly. I recommend 1/8 of an inch or 2 to 3 teeth above the workpiece. Other experts recommend up to 3/8 of an inch. The reason I like to recommend 1/8 of an inch or 3 teeth above the workpiece is if you're using another table saw manufacturer's saw, if you slip and you have that saw blade stuck 3/8 of an inch up above there, you're going to cut a groove in your hand 3/8 of an inch deep, which would require major surgery and or amputation of any affected parts. If it's only 1/8 of an inch, you're only going to cut 1/8 of an inch deep. Still going to be serious, but probably not as serious as going deep, cutting tendons, losing appendages or whatever. So I prefer to keep the saw blade lower. Okay, so with that, we're ready to make a cut. And I am going to make a cut using the gauge right here on the front. It's like a tape measure. I can set that to whatever I want. In this case, I'm setting it at 4 inches, so I'm going to make this board 4 inches wide. So in order to do that, I'll position the board so it is not in contact with the saw blade. If I have that saw blade in contact with the workpiece and I turn it on, it is going to launch that workpiece back at you at 103 miles an hour, and it is going to hurt. So make sure you're not in contact with the saw blade. You can turn it on. Next thing I want to make sure is that push stick is in a handy place. If I have it setting all the way over here, I can start to cut, but now I have to divert my attention over here to pick this up. I'm not paying attention over there, and I could slip and have a kickback. But if it is right here, I can easily pick that up and push it through. Real handy on real long boards that you're cutting. So you can still use the push stick, but it's out of the way until you actually need it. So I'm going to cut this. I push the workpiece all the way past the saw blade, and I wait for the blade to stop before I remove the cutoff piece. So that is a simple way to rip cut on a table saw, and very accurate. The guide or the tape measure on the front here is set, so you don't even have to double check with a tape measure, although it's good to check occasionally to make sure that something hasn't moved. But great, straight, accurate cuts each time. So the next cut I want to do is called a cutoff. The cutoff or cross cut is when I am cutting the board off on the end here, and I'm using this tool here. It's called a miter gauge. This is another safety device. Its purpose is to guide the workpiece straight past the saw blade. Again, you never want to try and guide this through by hand, because you're going to twist it a little bit, and if you twist while you're cutting, it's going to pinch the saw blade. It is going to kick back at you at 103 miles an hour. I can't emphasize that enough. So miter gauge is just another name for angle. So if I want to cut an angle, let's say I want to put a 15-degree angle on here, I just set this at 15 degrees, and now I can guide this through straight past the saw blade at a 15-degree angle. Double check, make sure the blade height is set correctly, and I take my cut. And with that, I've made a 15-degree angle. Very simple to do. The problem is, when we have a long board, now I only have a small contact area here, and I'm trying to control that whole length of the board with just this small contact area. So another thing we can do with this miter gauge is to add a sacrificial fence. The fence is actually screwed to the back of the miter gauge here with just a couple screws. Very secure, and now we have actually lengthened the contact area, so if I am cutting a longer board, I have a lot more support, a lot more control over that long workpiece to guide it through the saw. And I'm going to take another cut, double check. I got it set at 90 this time, or 0 on this. We'll take one cut. And there we have a nice, clean, straight cut. The workpiece fell off this side, no problem. Okay, the next cut that I want to show is cutting a groove. And when we cut a groove, we're not cutting all the way through the board. So that becomes a problem with the splitter, because the splitter is designed to maintain that saw curve on a through cut, which means that you're cutting all the way through the board. So I have to take the guard off. And I set it off to the side. I still need to maintain that saw curve though. So SawStop came up with this tool here. It's called a riving knife, R-I-V-I-N-G. And it is designed to maintain that saw curve as you're doing the groove. I just drop it into place, put the lever down. The nice part about this, the top of the riving knife does not go above the saw blade. It is actually just below the top of the saw blade, so it will follow in the groove without catching on anything, but it'll still maintain that saw curve, and it also helps guide this straight past the saw blade. So Next thing we want to do is set the height of the saw blade, which is the depth of the groove that you want to cut. And then we will set the location of the saw blade. I'm just doing 1 inch right here just as a demonstration. So now I don't have a guard on top of this, but the beauty of this is the workpiece itself is going to act as a guard because it's going to cover up that saw blade as you're pushing it through. Just keep in mind it's going to come out on this side. Always a good idea to have that push stick right handy here so you aren't tempted to put your finger over there right where that saw blade is going to come out. You'll have a push stick instead. So we are going to make a cut here. And it has cut a groove. That's the same width of the saw blade. In this instance, it's approximately 1/8 of an inch, maybe just a little bit less. But let's say that we want that groove to be wider because I want to fit a wider piece of wood into this. So I want to make the groove wider, so I'm going to have to take a couple more cuts. So I set the fence so it takes approximately the width of the saw blade, and I'll take another cut. I made it a little bit wider, but this doesn't fit in there yet, so I need to make it a little wider yet. And it is almost there. And there I've made the groove the width that I wanted. So now I'm going to show you a shortcut to do this quickly and more accurately than just guessing. So I have a background as a machinist. A machinist works in very precise tolerances. Most woodworkers aren't real concerned about anything real precise. So when I did this groove, I wasn't real precise. There's a little bit of a gap in it, but there are times that you want something to be just exactly right. So the best way to do that is to think like a machinist. With that, I'm going to employ a couple machinist tools, a dial indicator, and dial caliper. These are measuring devices. The dial caliper measures widths and thicknesses. A dial indicator only indicates movement. So with that, I will measure the width of this, I'll measure my groove, and I'll figure out what the difference is. Put the dial indicator on the fence so I can move it the exact amount that I want to take off. So to start with, I'm going to take the first initial cut. And since I have plenty of material there, I'm going to take one more cut. And now I have a groove that is too small, which is what I want. But I want to make sure that that groove is exactly the same thickness as this. So I'm going to measure this, and this measures 301 thousandths of an inch thick, which is just under 5/16 of an inch, but 301 thousandths of an inch. And I measure the width of the groove, which is 250 thousandths of an inch. So I want to move the fence over exactly 51 thousandths of an inch. So I put my dial indicator in place, and I set it on 0. And with it set on 0, now I am going to move the fence this way 51 thousandths of an inch. Depending on what side of the groove you're cutting, you may need to move the fence over this way or over this way. And went just a little too far, so I back up, and now I have moved it 51 thousandths of an inch. So if my math is correct, I should be able to cut that groove exactly correct this time. And there it is. I've got that groove exactly the width that I want. Now, I showed you how I could do the groove exactly correct, but I can also do the width of a board exactly what I want too. So instead of cutting all the way through the board, I am actually going to reposition this groove so I have it exactly 1 inch from this edge. Right now I have this set where it is just a little bit underneath that 1 inch, and I'll take a cut. I measure it with my dial calipers, and that says 1 inch, 34 thousandths of an inch. So I'm 34 thousandths of an inch off. Again, I will set up my dial indicator right on 0. And I'll move the fence 31 thousandths of an inch. I'll take another cut. And with that, I'm right on the money. So if you're doing precision work, use precision tools. For the most part, you can use a scale or a tape measure. A scale is a little different than a ruler. A scale is usually like a machinist scale. It's metal. It's graduated more accurately than a wooden ruler. And a tape measure is accurate too, but it's about as accurate as a ruler. So if you want really accurate measurements, you have to use accurate tools. So the next thing I want to show you is how you cut thin strips. What most people like to do is just use the riving knife, and let's say they want that strip to be a 1/4 inch wide. They will set up the fence so it's only a 1/4 inch away from the saw blade. You can cut that off, but now you have a thin piece of wood that can potentially get trapped between the saw blade and the fence, and now you have a thin projectile launched at 103 miles an hour, can do a lot of damage. I came up with a little bit different method that allows me to use the guard and the other safety devices on the guard, which would be the splitter and the anti-kickback balls. So what we do is we remove the riving knife, we put the guard back into place. Okay, now with the guard back into place, I use this device. Just a simple homemade push stick. It's a block of wood. I got a piece on top that will help hold the workpiece down. You can make them whatever thickness you want. And I put a hook on the end here, so now I can guide it through. What I need to do though is to raise the saw blade to allow the push stick to go under the anti-kickback pawls. I'll move the fence over to whatever thickness I want to cut, and now I am ready to cut thin strips and do it all with the safety devices in place. And with that, I've got the thin strips I need. They're repetitive. The guards are in place, so it's a very safe way to do this. But I've got another alternative. This alternative works on basically the same principle, but this allows me to cut thin strips on a very long piece of wood. I have a simple little device right here on the end. When I have it turned down like this, it hooks onto the table, so it holds it in place as I'm pushing the wood past. But once I get to the point where I need to push with the push stick, I just push down on the little lever here, and now I've got the hook on the side, which allows me to push that workpiece all the way past. So I'm going to demonstrate that for you right quick. So the first thing I do is set the width to where I want it. It's approximately 1/4 inch. I'm not going to be real accurate right off the bat. And I want to set the saw blade so it is just above the height of the push stick, so I can push it underneath those anti-kickback pawls. Notice if I try to pull it back through, I can't, because that's exactly what the anti-kickback pawls are designed to do. I have to push it all the way through, and now we are ready to cut. I'm going to rotate my little stop here so it catches on the front of the saw, so it's not going to move as I'm pushing this long board through. And we are ready to take a cut. And with that, I have safely cut a nice thin strip of wood very safely. Okay? Once in a while, you're going to want to cut an angle instead of just a 90-degree angle. Let's say that I want to cut a 15-degree angle. So I come down here to this hand wheel on the side, and I rotate that. And right on the fence is a protractor with a pointer, and I can set that to whatever angle I want. Notice I didn't have to take the guard off in order to tilt it. On a lot of table saws, the way they rotate, you would have to remove the throat plate, rotate it, have a special throat plate in place with a real wide groove. But SawStop did everything right when they designed this. You can rotate it with the throat plate in place, and the throat plate, or the angle, also tilts away from the fence. A lot of other table saws will rotate towards the fence, but now you have a workpiece that is trapped underneath the saw blade and against the fence. Much better chance of kickback. But with this, it rotates it away from the fence, so now it's out of the way. I'm going to adjust the height, which again I can do with everything in place. So I'm just cutting through the board. I can drop the guard down, and we are ready to cut. Make sure everything is free and easy. Using my push stick, and with that, I have put a 15-degree angle on my workpiece. So you can do just about anything you want on a table saw.